So let's actually do it. Let's construct a confidence interval for the mean when sigma is unknown, small samples. And now you may recall that the margin of error, the maximum error of the estimate when you're dealing with large samples was this one. Z, the critical value of Z times sigma over square root of n. But now we don't know sigma, so we're going to replace it with S, and when I replace it with S, I have to use the t distribution. And just to make things real clear here, I hope to make it clear, this E right here I have with a critical value, all right? There's two things that you need for this, right? If you do this, because we just did an example, that error is going to be t, but t depends on two things. You need the degrees of freedom and you need the critical value. So I'm just going to write them both here, just to remind me that that's what I have to look up, times S over square root of n. And here's our formula for a confidence interval. It's going to be x bar, right up here at the top, x bar plus or minus the maximum error. But let's expand it so everything's right in front of us. We'll have x bar minus the error. That's less than or equal to the mean, which is less than x bar plus the error. And now I can even get rid of that error because I know what it is. How about this? X bar minus, all right, now that error, that's this down here, is going to be t, and I need two things to get to t. I need degrees of freedom, and I need level of confidence, times S over square root of n. That's less than the mean, which in turn is less than x bar plus that critical value, degrees of freedom, critical value of t, times S over square root of n. I like this way of writing the formula because everything is right in front of you. Just as I go from left to right, I see exactly what I need to put in. Here's an example I got out of the book. It says, over the past several months, an adult patient has been treated for tetany, severe muscle spasms. All right, so this condition is associated with an average total calcium level below 6. All right, so on the average, you get this condition if your total calcium level is below 6 milligrams per deciliter. Okay, and they've referenced it here. Recently, the patient's total calcium tests gave the following data. All right, so here's this data. What do we have? We have how many pieces? 2, 4, 6, 7, 8, 9, 10. So we have 10 pieces of data. Then the directions say to use our calculator to verify this. Okay, I'm going to show you how to do this real quickly. If you know how to do it or just want to believe it, you can just speed this thing up or fast forward and get to the computations. So here's the directions to do that. So on your calculator, you're going to press Stat, select number 1. It's Edit. Then get your cursor just under the L1. So when you press Stat and Edit, you get an L1, a bunch of lists. So get your cursor right under the L1, right under the L1. And if there's already data there, just press the delete key. Just keep pressing it until all the data is gone. There's another way to do it, but this will work for us right now. Now the delete key is right up there in row 1, column 3. So delete all the data. Then type in these numbers, these 10 numbers, right? So you type in all the 10 numbers. A number like 9.3, enter. 9.9, enter. 8.8, enter, and so on. You get all those in. Then what you want to do is press second quit, right? They're right next to each other. That gets you out of the editor. So second quit, you're back to your computation window. Now, press Stat again. We use that key a lot in this course. So press Stat again, arrow over to calculate. So calculate, just press Stat, go over to calc, and then select number 1. And what comes up is one variable statistics. We only have one variable. Right, our variable in this case is number of milligrams per deciliter of total calcium. All right, so one variable, statistics. Select that one. What comes up is list, frequency, and calculate. Now your list, all your data was in L1, right? So you got to get to L1. So you want to be sure you have an L1 there, and if it's there, great. If not, we'll put it in there. How do you do it? Press second, and then down to the number 1 key. Right, just down on your keypad, number 1. All right, right above 1, right above the 1 key down here at the bottom, right above 1, it says L1. Now once you have that, press enter, and there it is. All right, so you press enter, and what you want comes up. And sure enough, what I got here when I did this matches what they're saying they got. So let's compute. Now we have n equals 10, and I know it's a t-distribution, so I know I'm going to need degrees of freedom, which is sample size minus 1, 10 minus 1 in our case. So the number of degrees of freedom we're going to use is going to be 9. Now, here's our formula right here. I've got it right in front of me here. Now, let's just substitute numbers in. So first up, x bar. Well, x bar, we just verified that that was 9.95. So we're going to get 9.95, then minus. Now, I'm going to write this out. Do it a couple steps. I need the t value, but I need two things to get that. So I'm going to write it down and then I'll go to the table and get it. So I need degrees of freedom and the level of confidence. So here's what I'm going to write. Just to remind myself, I need to go get that t with 9 degrees of freedom at, what are we doing this with? We want to do this, oh, it doesn't say. So let's just make something up. Let's say we do it at 99%. Okay, so I'm going to do this at 0.99. Okay, 99%. Now, I have to go look that number up, but now I'm going to get times what? Times S. What is S? 1.02. It's a fraction. 1.02. And then what? Divided by, where'd it go? Square root of n. Square root of the sample size. Our sample size is 10, so it's going to be divided by square root of 10. Now, this will be less than the mean, which is going to be less than the same thing, but with a plus sign over here. So it's going to be 9.95 plus that t at 9 degrees of freedom at 0.99 times 1.02 over the square root of 10. Now, we need to get this value. We need to get this. So I'm going to go to the table. I just popped the table in here. Let's see if we can read it. Remember, we're up here at confidence levels, and we have 3 rows up here. The first 2 are for what comes in the next chapter. This is one we want, where it says C, for confidence level. So we have 9 degrees of freedom. So I'm going to go down to row 9, and we're over at 99%. I follow it over carefully. The very last one is 99.9%. We're at 99%. So I'm right here. And what do we get for 9? I think it's that one. 3.250. So I'm back out of the table, and I'm at 9.95 minus 3.250 times 1.02 over the square root of 10. That's less than or equal to the true mean, which is less than or equal to, okay, same thing but with a plus, 9.95 plus 3.250 times 1.02 over the square root of 10. Now what I'm going to do here is I'm just going to compute this maximum error. Just compute the margin of error because it's sometimes convenient to report that. So let's just compute this. So on my calculator I typed in, let me get it to right here. Here's what I typed in. Okay, I typed in 3.25, I don't really need a 0 for it, times 1.02, press the divide key, and then I typed the square root. So I pressed second square root, or second x squared, and I put in a 10. And when I did this, I got 1.048, say. So now I can write this like this. I've got 9.95, and then I'm going to subtract this value and add it. So why don't we just write it like this? Plus or minus 1.048. Okay, so oftentimes you'll see an interval written like this. You know that that's the sample mean right there. Plus or minus, there's your error. But if I actually do this now, where I type in 9.95 and then minus 1.048, okay, then that's going to be less than the mean, less than the 9.95 plus that 1.048. They'll actually do those, and I'm going to come up with this. I get 8.90, less than or equal to the true mean calcium level, less than, now add them together, and I got 10.998, or how about if I round off, 10 point, well, if I round off, what does it come out to be? I round that 8 up to the 9, to the 10, I end up with just 11 here. All right, so I'm going to write that. I'm just going to write 11. Right, there's our confidence interval. Let's interpret it. So here's probably a good way to say this, to interpret this. We can say the probability that the interval from 8.90 milligrams per deciliter to 11.0 milligrams per deciliter covers the true mean calcium level. That probability is 0.99. And what does it all mean? Well, it means this. Since the entire interval is above 6, we're 99% confident this patient is not calcium deficient. Remember what it said over here? It said this condition is associated with average calcium level below 6. So if you're below 6, you could suffer from tetany. But look at our interval. Our interval is all above 6. I'll draw a little picture here, right? So here's 6. Our interval is above 6. So we're 99% sure that this interval here covers the true calcium level. So it's all above 6.